7-digit number and it turns out to be a prime number. Now you can probably, intuitively speaking, it makes sense that prime numbers are more densely packed when you have smaller numbers, like say from 2 to 10, you have more prime numbers in terms of proportion, and then from 10 to 20, you don't have as many. So when you move up to 8 digits, it is hard to find the prime number. You find non-prime numbers pretty quickly like that, but it's really hard to find actual prime numbers. So I was just, it was just, luck of the day. I picked a number that is like 28 million something, and it turned out to be a prime number. Okay, so now we have 751. 751 itself is it divisible by something else other than itself? Well, we know that we don't have to try 7 anymore because we have already exhausted all the 7s. 11, we can try 11 again. I don't think it's divisible by 11. So that's not the case. We can try the next one, which is, 13? Nope. So it's not divisible by 13. Now, as we try it, okay, you might be thinking, oh, Tech, you're just wasting my time. You should have done this before coming to the class. But that's really not the case, because what I'm showing you is exactly what your program needs to do. Okay? Because if you cannot tell right away that this has like a particular number as a prime factor, neither can the computer. The computer natively can only do very simple things. Okay? If I have to go all the way down to the processor level, at the hardware level, with slower and less expensive processors, they can only do addition, subtraction, and comparison. That's it. They cannot natively do division. They cannot natively do multiplication. Okay? So if you cannot do it just like that, that means the computer cannot do it just like that either. All right. So, but this is a good example already, not only illustrating how we can find all the prime factors given a number, but also just how to find a prime factor of a single number. Okay? Because with 751, it's big enough that you cannot right away just say, oh, it's divisible by 3, oh, it's divisible by 7. Okay? Whatever it is, it could be just a prime number too. Okay? For all we know, it can just be a prime number. But it is already forcing you as people not to rely on your rules of thumb. Okay? That's the first thing you have to remember is when you try to write an algorithm, one, you have to first understand what the problem is. What are you asked to do? And people who have taken the visual basic class understand at least that part is like in your brain already. But the second thing you also have to do is not to pick samples or examples that are really easy to do. You have to pick something that is complicated. That will force you to use a systematic way to solve the problem. Am I okay so far? Making sense? So in this case, 751 is most likely a prime number. So then you can just conclude and say 751 is a prime number. It can only be multiplied by 1 and itself, and then we are done. There's nothing else to do because now there's nothing. We know that we have reduced the original number to 1, and you cannot reduce 1 to its prime factors because 1 is not even a prime number itself. Okay? But this is showing you quite a few things already. One, do you think we might need to rely on a loop of some kind to find all the prime factors of a given number? And the only thing you know about that given number is it is greater than or equal to 2. Do we need to do something again and again?
Yeah.
Do we have the potential that we have to do something over and over again?
You have to.
Yeah, well, look at this example here. We start with this number. We find one prime factor, but we have a remaining portion. We have to apply the same technique to the remaining portion and find another prime factor, but now I have a smaller number that I still have to chop it down into even smaller pieces. I do the same thing again, the number gets smaller. I do it again, the number gets smaller, but this time it got reduced to 1, and I can finally stop. Okay? So what this is telling you is we have to rely on some kind of a loop. I don't have enough time today to basically finish the evolution of the algorithm, but I can do this much. Okay? The first revision, okay, if you prefer, I can call this revision 1.0, my algorithm will simply look like this, loop and loop. No, we do not actually have a control structure called loop, but I'm just saying that we need some kind of a loop. I do not know yet whether it is supposed to be pre-checking loop or post-checking loop. We can deal with that later. But I know that we need some kind of a loop. Now, whenever you have some kind of a loop, you also need to know, is it supposed to be an infinite loop? No. This one does exit at some point. At some point, we are done. So when are we done with this loop here?
When is the only multiple is divisible.
When 1 becomes the number to factors, right? So we'll write exactly that. So we'll say end loop when 1 is the number to factor. And I will call this revision 1 of my algorithm. It doesn't even look like an algorithm to me, but it is important. Okay? There are two things that are already very essential in this revision 1, even though it doesn't seem to be very important at all. One, we have identified that we need a loop. Okay? And the second thing is, when are we going to exit the loop? It does not look like an algorithm. It does not use variables the way we usually do. It does not specify what we are doing in the loop. It does not even specify whether it's a pre-checking or post-checking loop. But we don't want to identify all those things all at the same time. Okay? When you write an algorithm, when you construct an algorithm, or when you design an algorithm, you start with something that's vague, and then you try to add more details later, step by step. Okay, so the key point here is step by step. You start with kind of fuzzy and kind of vague, but it still captures a good part of what we need to do. So we'll start with this next time, on next Friday, and then I'll show you how I will go through its different revisions. And with each step, I just add and clarify something. Okay, and then at the end, we'll end up with an actual algorithm that will solve the problem. Okay. So right now, what I'm explaining or what I'm illustrating here is not in the class notes because it is really hard to test this part. Okay, I cannot, say involve this program, and stuff like that. But I think it is important if you want to get into programming. Understanding how to design an algorithm is a key part. I should say that let me tie a shoelace first, because otherwise I might be kissing the cold nose. Save it.
So the first exam is from 60 point, right?
The first exam has 60 points, but the whole thing only.
How many for A? For getting A?
To get an A,
How many?
you need 87.5%.
No, I mean in the first exam.
Same thing.
87. Okay.
60 points times 87.5%. That's. I don't even bother with level grades, with individual tests, but if you want to know where you stand in the class, that's the number of points that you need. Yep.
I just want to share what I did because I found it so funny when I realized what I did. On 3, it was so easy that I was that must be an else. And I just invented in my head because it seemed too simple. And then I went back to 1 and made it an else.